Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is any variant. Before proceeding, make sure that you have already watched these other videos first. The term new vocabulary types is sometimes used to collectively refer to three new features of the C++ language: any variants, templated variants, and optional values. A C++ variable is always defined as having some data type, and it has that same type throughout its lifetime. An any variant is a variable having a special type which simulates the ability some other programming languages have, where their variable can store differently typed values at different points in time. You can query to find out which data type is being simulated. You will need to specify that simulated data type whenever you want to access the value that's being stored in the variable. The result of making this call is a compiler temporary whose type actually is int. The same any variant variable can be reused, and the simulated data type can change. Assume that this any variant is currently simulating an int type. Somewhere within its internal implementation, there is an int-sized storage of the actual data. You can cause an int pointer to point at that portion of memory located somewhere within the any variant's internal implementation. Or, if the any variant had actually been simulating some other type, then you just receive a null pointer in return. An any variant could be uninitialized. Default construction would initialize it to a special no value state. Otherwise, it could be initialized using the same syntax as any ordinary variable. An any variant variable could be manually put back into that no value state. Because any variants support copy construction, they can be conveniently passed by value into a function or returned by value from a function. An any variant can take an object as its value. You could first create an object and then have it copy constructed into the any variant variable. Because you're now working with a copy, any changes to the original object won't affect you. Again, either implicit or explicit initialization could be used. Or you could use a utility function that directly creates a compiler temporary with that object value. When that directly created compiler temporary is used in an explicit initialization, there exists an alternative syntax you could use for it. You can assign an object value to an any variant variable, just as you can assign any kind of value to it. Assignment can also use this utility function for creating a compiler temporary that gets assigned to it. But even more efficient is the mplace function, which does this assignment without the need to create any compiler temporary. If assignment is done to an any variant which currently had an object value, then that object value does get properly destructed. Alternatively, you could modify part of the existing object value without completely replacing the whole thing.